All right, today we're going to be talking about simplifying radicals. Radicals is a skill. Being able to simplify and work with radicals is something that you're going to need as we get deeper into this quadratics unit, when we get to things like the quadratic formula and solving by completing the square. You're going to need to be able to deal with radicals. So we're going to learn how to simplify these things. And the good news is it's not particularly difficult. Before we get into the actual act of simplifying radicals, let's talk. There's some sort of stuff that you need to know. The number one thing that you need to know is you need to know your perfect squares. Everything hinges on you knowing your perfect squares. Now, a perfect square is a number whose square root is an integer. Okay, and we remember that when we're talking about an integer, we're talking about a number that doesn't have a fraction or a decimal. It's just negative, positives, or zero, numbers like -2, 0, 5, so on and so forth. So when I take the square root of these perfect square numbers, I get an integer. Okay, so I need to know what these perfect square numbers are, and so what I'm going to do is I'm going to make a list of these numbers right over here on this side, so that way I can refer back to this list as I'm doing my simplification. And my hope is that on any piece of paper that I put in front of you where you need to simplify some radicals, you're going to recreate this list as well. And that way you can refer back to it as well, and I think that's going to help you out quite a bit here. So to generate the list, it's really very easy. You just do 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, so on and so forth, and you can generate this entire list. And these numbers are the perfect square numbers. And I think you should be able to go up through 15 times 15. I think that's a fair place to go. 13 times 13 is 169, 14 times 14 is 196, and 15 times 15 is 225. So here's my list of perfect square numbers, and I'm going to refer back to this list quite often during this lesson. Okay, so let's talk about the actual act of simplifying. And before we do that, actually, let's actually talk about some vocabulary that's used in radicals here. So let's just put down a typical radical expression, something like 3 radical 12. Okay, so let's label the parts of the radical here. So this piece out in front, the 3, that's just a coefficient. That's a coefficient. And this symbol, you all know it, that's called my radical. Whoops. C-A-L, radical. And this number that's underneath the radical sign, that's actually called the radicand. And we don't refer to it all the time as that, but that's actually what it's called. It's actually called the radicand. Now, we also need to talk real briefly about irrational versus rational. I just want to bring this up again. If you take the square root of any of these perfect square numbers, you get an integer. That's what we were talking about a minute ago. That means that if I were to write something like radical 49, radical 49 equals 7. So that means that this here is rational. However, if I were to write a number in the radicand that's not a perfect square, like say 5, and I go to put that in my calculator, I'm going to get 2.23606 ... That is a non-terminating, non-repeating decimal, so that means that radical 5 is irrational. When we're simplifying radicals, if it's rational, you just take the square root. But if it's not a perfect square number in the radicand, then that's when we're going to be simplifying, because my response is actually irrational. So I'm going to simplify instead of actually telling you what the actual square root is. All right, so let me show you what I mean. Let's start with that radical 12. What I want to do is I want to take this and I want to put this into simplest radical form, okay? Because 12 is not a perfect square, so radical 12 is irrational. So what I want to do is I don't want you to tell me what the square root of 12 is. I want you to just instead simplify this into simplest radical form. So here's what I'm going to do. I can rewrite 12 as two numbers multiplied together. And I want one of those numbers to be on this list. So if I were to go over to my list here, 12 would be right between 9 and 16. That's where 12 would appear in order. So what I want to know is, which of these numbers that are less than 12, what is the biggest perfect square that goes into 12? So does 9 go into 12? No. Does 4 go into 12? Yes. 4 times 3 equals 12. This number needs to be the biggest perfect square. This needs to be the biggest perfect square factor of the radicand. If it's not a perfect square, then you're not going to get very far. And if it's not the biggest perfect square, then you're going to have to repeat this process. So we want the biggest perfect square factor of 12, which is 4. Now, with radicals, if I've got two numbers being multiplied, I can actually rewrite that as radical 4 times radical 3. So this is my process. I'm going to rewrite 4, because 4 is a perfect square. I'm going to rewrite that as 2 squared. And the radical 3 just comes along for the ride here. Now, here's where the magic happens. Squaring a number and taking the square root are inverses of each other. Just like adding and subtracting are inverses of each other, multiplying and dividing are inverses of each other, they undo each other. So the radical symbol and the squared symbol undo each other. They're inverses of each other. And what am I left with? I'm left with just 2. And then the radical 3 gets written right next to it. And that is radical 12 in simplest radical form. I haven't changed the value, I'm only simplifying. So if I were to put radical 12 in my calculator, and then I were to put 2 radical 3 in my calculator, you're going to see that they're exactly the same. So that's how we simplify radicals. Let's do one more example together. And I'm going to add some additional notation here that I don't want you to worry too much about. Let's do minus 2 radical 98. Okay, there's my next example. All right, step number 1. I'm going to leave the negative 2 out in front for right now. I'm going to worry about that later. What I want to focus on right now is the 98. I want the biggest perfect square factor of 98. 98 would appear right here. So I have to check all these numbers below it to see if they go into 98. You would use your calculator for this. If I were to do 98 divided by 81, I'm going to get a decimal, so 81 is not a factor. 98 divided by 64 is a decimal, so 64 is not a factor. 98 divided by 49 is 2. So there's my biggest perfect square factor. It's 49. So I'm going to rewrite this as negative 2. And then inside, I'm going to put 49 times 2. The negative 2 is just going to keep coming along for a ride. So now I've got negative 2, and then 49, I'm going to rewrite this in this way. Now 49 is 7 squared. This is where the radical symbol and the squared symbol undo each other. And what's going on between the negative 2 and this radical? It's being multiplied. So this is negative 2 times, I'm left with just 7, times radical 2. Negative 2 times 7 is negative 14. And I'm left with radical 2. And there it is, simplified. One last little symbol that you might see, and I don't want you to be surprised. Notice that if there's a negative sign out front, there's probably going to be a negative sign in my answer. If there's a positive sign out front, then I've got a positive sign in my answer. And one more symbol that you might see is this symbol right here, and I don't want it to startle you. You might see something like this. This just means we're lazy as mathematicians. This just means I want the positive simplification and the negative simplification. No big deal. When I put my final answer, I'm just going to include that symbol out front. We'll talk about that symbol a lot more in future lessons, but for now, whatever symbol you see out front of your radical, that symbol should be out front of your final answer as well. Okay, that's it for this lesson.